Hello everyone. This is our fourth lecture on electrical machines, and this is a delayed lecture. First of all, I am sorry for that. Today, we are discussing about armature reaction, and in the previous lecture, we have already discussed about EMF equation of DC machine. So, armature reaction. As we have studied about EMF equation, construction, introduction, classification. So we have idea about what armature is. So armature for a DC machine is basically the rotating part of DC machine. So what is armature reaction? We can define armature reaction as the effect of armature magnetic field on the main magnetic field that is produced by poles, or say field poles, that results in demagnetizing and cross magnetizing effects. So now we will discuss and say solve this and try to understand what does that term means. So take a simple machine when not started. This is North Pole, this is South Pole, and this is the direction of main magnetic field. Now, the perpendicular to the main magnetic field is known as GNA, Geometrical Neutral Axis, and the perpendicular to the magnetic field of rotor, say this, is known as MNA, magnetically neutral axis. So the key point is brushes of a DC machine or a machine are always placed on MNA. So there is no supply to the machine, so the rotor is stationary, and the direction of main magnetic field is north to south pole, that we see is a straight line. So direction of main magnetic field is in this direction. Now when we connected supply to the rotor or armature, the armature starts to develop its own magnetic field. See this. The direction of this magnetic field can be find out by using right hand thumb rule, which may define the direction of magnetic field on the open and closed path of winding. It is upward here, downward here, here and upward here. So due to this, see, on this side the direction of magnetic field is upward and in the center is downward. However, in the at the north pole side is also upward. So the resultant magnetic field will be suppose the magnetic field of main magnetic field come here, and due to this, say this upward, it pushes that upcoming, see this is main magnetic field coming upward and this is the rotor magnetic field which let it go upward. Say see this again, and the rotor field tell it to move upward. So by this we can say that it moves upward, and as it reaches that point, see the magnetic field is highly downward. First downward here and second downward due to here. Now say it is going upward, and then from upward highly downward, or say this. So the magnetic field going upward will be pushed downward like that, and after reaching that point, say this is coming downward, it is again moved upward, slightly upward, making the starting position of, or making it to reach its starting position. All the magnetic field lines follow the same path. Now the magnetic field across the rotor, or say M and A, is moved, and the G and A is same. So see this, the 0 point, and this is resultant force F, which we call as armature reaction. It produces two effects. As we see, for the first one, this, the direction of main magnetic field here is this direction, and the direction it shows is completely opposite. So it demagnetizing, it is demagnetizing, or I'll say weakening the main magnetic field or flux. So as the name suggests, The demagnetizing effect will weaken the main magnetic field, and the other effect is this. Say this is the direction of main magnetic field, and this is the direction of rotor magnetic field or armature magnetic field. This produces sparking due to cross magnetizing. See this. Though the two magnetic field intersect each other, say one coming from this side, one coming from this side, and they collapsed and sparking produces at the brushes. It is cross magnetizing. So we have studied what armature reaction is, how it is produced, and how many effects are there of armature reaction. So the question arises is how to reduce armature reaction. Can it be completely demolished or completely vanished? So the answer for the second question is no. Armature reaction can never be completely vanished or completely struck off or completely destroyed. It is a practical case that armature reaction always have some effect. However, we can reduce it but not completely vanish it off. So there are methods which are used to reduce may the armature reaction. First one is interpoles. As the name suggests, poles. What we do is like this is a side view of machine. These are main poles. What we do is simply provide small poles between these poles, that increasing the magnetizing of main magnetic field, or the film or the magnetic field due to the poles is increased by providing them strong magnetic materials and more winding turns. And the second method is concentrated winding. Just adding some more number of turns in the arm in the field winding is concentrated winding. Or the focused winding, say the number of slots equals to number of poles, sorry, number of slots equal to number of turns. This will also reduce the armature reaction. So for armature reaction, that's all we have to tell you. So thank you for watching the video. That's all for today. For the next lecture, we will discuss about classification of DC machine in detail, using or finding their equations, voltage and current relationships, and so on. Thank you.